We are moving on to the second set of examples, which is asking us to solve using trigonometric identities that we have seen before. So this first question here, if you guys remember, it might look familiar. This is a question from one of our previous worksheets. We tried to solve it using integration by parts, if you remember correctly, but it did not work out, right? So, and at the time we said, what you might use here are the product formulas. So basically all the identities that you guys are familiar with for multiplying two trigonometric expressions, especially sine and cosine. So first of all, I want you guys to try. So basically what I want you guys to do is use those identities to change this product of the two trigonometric functions into the sum or the difference of two trigonometric expressions using those product formulas. So I want you guys to attempt it and then give me what you get, so we move from there. So this is equal to what integral, basically? So
give you the answer.
Sorry?
I mean, wait, sorry. Did you say we should do it on our own?
No, I want you guys to change this product from a product to a sum or a difference. So use the product formulas for the trigonometric identities. I'm not sure. Are you guys familiar with the product formulas? I know you are. You must be. Yes. So use those.
So you'd have integral,
right,
of sine 8 minus 3.
Sine 8. Did you forget something before the trigonometric expression? What comes first?
1/2.
Yes, thank you. So 1/2.
Wait, there's another one. Do you know the one that goes? I'm checking if we can apply that. Goes sine 8 minus 3t, then it's gonna be plus times t. No, it's just sine 8 minus 3 at first without the t's, then times t. So you could have had the t actually.
Outside, yeah, okay.
Not outside. It ends up being inside, being part of the angle. It ends up being sine 5t.
It's all the same.
Okay, cool. So then minus or plus sine 8 plus 3t. I'm not minus or plus. I'm not sure which one it is. I just forgot for now. But there's one that goes like that.
Yes, those are the product formulas. But there's one
the same thing you're applying right now. Is it the same thing you're applying right now?
Yes, but there should be a 1/2 that's missing in the formula that you just gave me. Yeah, because I'll just write it down here for just as a revision for you guys. When you have sine of x multiplied by cos of y, the formula tells us that this is equal to 1/2 multiplied into sine of x plus y minus sine of x minus y. So that's the formula. Right, so now let's apply it to our expression here. So we have 1/2 multiplied by sine, right, of our x in our case can be just 8t, right? So 8t plus 3t, which will be 12t. Oh, no, not 12, but 11, sorry. 11t minus sine of 8t minus 3t, which is 5t dx. So now we have the sum of two trigonometric functions, which we can easily integrate, right? So the 1/2 will stay out. The first integral, what is the integral of sine 11t dx? Oh, well, sorry, this should not be dx, it should be dt.
Minus cos 11t divided by 11.
Yes. And about the second one?
Plus cos 5t divided by 5.
5t divided by 5. Hopefully everyone see where that comes from. So then, now that you have that, obviously you have to include the constant of integration there. But that's basically what your final answer should be. Right. Any questions there? Any questions at all? Just go ahead. Is there a question?
Sorry, sir. Are you sure? Yeah. Are you sure that the question, the formula looks like that? Because that is not what Mr. Mhlango gave us on his note.
Which one is the one that he gave you?
He did give us that. Let me double check.
It says sine, the integral of sine mx cos nx dx is equal to half times the integral of sine m minus nx plus sine m plus nx.
Sorry, let me just write that down. You said the integral of sine
mx cos nx
dx, right, is equal to half
integral of sine m minus nx.
N minus mx, okay.
M minus n.
M, right, minus n, okay. Right.
Plus sine.
Plus
sine of m plus nx.
M plus nx. Did they give you rules on what m and n are? Is m greater than or lower than?
No, he didn't mention anything like that.
Because it's important. Well, okay, so there's an easy way to do this. So let's take the formula alone. Let's leave out the integration, right? Let's take the formula alone. So let's expand this and let's see if we find the original question, right? That way you know. So sine of m minus n x is equal to what? Is equal to, remember, the double angles. What's the formula there? Asking you.
Sine m cos n.
Some m cos n x, right? Then
minus cos m
sine
x
n x, right? And then for sine of m plus n x, you have sine, basically sine m x cos n x plus cos m x sine n x. Okay, so add this, you get 2 sine mx cos nx, which is why you put the half there. So this is correct. This formula is correct. So that's the formula that he gave you. So now let's, and it's true. Okay, so if he gave you the formula, then it is correct. Okay, so now let's check the formula that we are supposedly using. So let's try. All right, so let me change what. Okay, so let me erase this. And I'll just take the formula. But you see that the formulas are similar. So what we might be discussing here is just issues in the signs and stuff. So let's try that. X plus y minus sine of x minus y. So let's try that. If it doesn't work, then there's a problem with our formula. Oh, sorry. I think, yes, there's a problem in my formula. This should be sine of x of y minus x. That's where I made the mistake. Sine of y minus x. But okay, so then this would be sine of negative 5t which is just the same as, let me rewrite this, which is just the same as the integral of half multiplied into sine of 11t, and the sine of negative 5t is just the same as the sine of minus the sine, so we minus minus, so plus sine of 5t dt. Okay, and then you can integrate this. So that's why I made my mistake in the formula. So my formula should be x minus, no, not x, y minus x. So that when you expand, you have 1 over 2 sine x cos y plus sine y cos x minus sine x, sorry, not x, but y, sine y cos x minus minus, so that would be plus sine x cos y. This would cancel with that. These two would add up to get half multiplied into 2 sine x cos y, which is the original expression, right? And the 2 cancels there. So hopefully that makes sense. Does it? Any questions about this? So basically rely on the formulas that he gave you, right? But since you guys are familiar with trigonometric expressions, you should be able to sort of use those formulas and get your answer without having too many problems, right? So it's basically just applying the formula. But then again, you can memorize it. I don't like to say memorize this, but because you might make a mistake in terms of signs and stuff. So just get used to using it. I guess that's how I'll say it. Get used to using all formulas. This is just one of them. I think there's 3 of them. There's sine, cos, and this is sine, cos. So just get used to them, and yeah, you should be able to easily apply them in a problem, right? So let's see how we can solve this one now. So for this question, we have the integral of tan to the 5t multiplied by sec to the 7t. And now I'll ask you, how can we solve this? Where should we start? Suggestions? Anything?
Change the 10. No.
Sorry, change the 10 into what?
Okay. Hold on.
Anyone else? Come on, guys. There's 19 of you in here. Speak up. Come on. Well, if you think about it, our question has 10 and sec. What's the relationship between 10 and sec?
One is the derivative of the other.
Other than that, in terms of trigonometric identities, what's the relationship between the two? Isn't it that you have 10 squared of t is equal to sec squared of t minus 1?
Yes.
So you don't have that correlation. So you can apply it to the expression, right? So if 10 squared is equal to that, 10 squared, which is 10 to the 4, is just that squared, right? So just apply that there. So 10 to the 4t multiply, I'll just break it down first. By 10 is equal to multiply by sec to the 7t dt. Now, simplifying this by using the expression that we derived there, this is equal to the integral of sec squared t minus 1 sec squared multiplied by 10 t sec to the 7t dt. Now, at this point here is where we could use what to solve this? As a hint, someone has already mentioned a relationship that we can take advantage of between sec and 10.
Use substitution.
Use substitution, right? So thank you. So what should we substitute as our u?
I think it's 10.
Sorry?
Oh, it's 10.
10. Think about it.
No, it's sec. I think it's sec squared.
Yes, sec. We can use sec, for example.
Okay.
Because if you think about it, if you use
10,
10, think about it. If you use 10, your u will only be this, basically, the 10 that's there. All these other terms of higher degrees to the 7 will just stay the same, which doesn't really simplify your integral, right? So the only other expression or the only other function that you can use there is sec. So let's use sec. So if we substitute u equal to sec t, we have du therefore is equal to sec t times 10t, right? dt. Once again, remember your trigonometric identities and your derivatives. So now that you have that, bring it back to the expression. So now we have, you know that sec is u, so we have u squared minus 1, right? Squared times, we have 10 multiplied by one of the sec that's there, right? We can use one of the sec that's there to give us du. So we have du, well, let's not put du first. We'll be left with the sec to the 6, right? So u6 du. Does that make sense?
Yes.
Yes.
Then you can break this up, right? You can expand and have a term and basically a sum of u's, and you can integrate that easily. So when you expand that, it's u to the 4 minus 2u squared plus 1 multiplied by u to the 6 du. And this is equal to the integral of u to the 10, right? minus 2u to the 8 plus u to the 6 du, which is equal to u to the 11 over 11 minus 2 u to the 9 over 9 plus u to the 7 over 7 plus c. And what is our u? Our u is sec. So this is just equal to sec to the 11 t over 11 minus 2 sec to the 9 t over 9 plus sec to the 7 t over 7 plus c. Does that make sense?
Yes.
Any questions at all concerning this? All right. If there aren't any, let's just move on to the next expression. Okay, so now something similar, but now we're dealing with sine and cos. Using the same idea, basically, that we did in the previous example. What should we do to simplify this expression?
Are you going to
Sorry?
break up the sign again?
Yes, so you could choose to either use sine or cosine. Let's say we use sine first. What should we
Sine to the
use?
4 and then sine.
Well, yeah, so we know sine squared t is equal to 1 minus cos, right? Squared. Right? We know that.
Yes.
So therefore, sine squared, which is sine to the 4, is just this squared. Bringing it into the expression, we have sine of t multiplied by sine to the 4 t multiplied by cos to the 4t dt. And this is equal to sine t multiplied by 1 minus cos squared t squared, right? Multiplied by cos to the 4t dt. Right?
Yes.
Expand when you, well, you don't even need to expand it. At this point here, what do you think we can use to solve this?
Let u equal cos.
Right. Once again, if you think about it, it's better to let u equal to cos rather than sine, because sine is just one, is a simple sine function. There's no exponent there. So all the other functions have higher and higher orders. So we would rather have our u be equal to cos t, so that we have du is equal to negative sine t dt. And then when we bring it into the expression, we would have now, there's a negative here that's in this expression that we don't have in the integral. So we'll have to bring it in. So basically multiply and divide by minus 1. So, but anyways, before we do that, let's first substitute our cos. So we have 1 minus u squared times u to the 4. And now we're left with sine t dt. But we don't have a minus there, so that would be minus du. So basically multiply by minus 1 there on both sides. So then the minus will come out of the expression. We are left inside, and we expand. If we expand this expression, we have 1 minus 2u squared plus u to the 4 multiplied by the 4 du.
Jonathan?
And this would be equal to, yes?
Would we have gotten to the answer if from the initial thingy we instead let the cost equal to 1 minus sine squared t to the 2?
If you guys want, we can try that as well when we're done with this and see where it gets us.
Yeah.
Yeah, so then when you expand this further, you have the integral of u to the 4 minus 2u to the 6 plus u to the 8 du, which is just minus u to the 5 over 5 minus 2u to the 7 over 7 plus u to the 9 over 9 plus c. And our u is cos, so we have minus cos to the 5 over 5 t. If you're going to write down these solutions, you'd rather write them down now because I might have to erase to make some room for the other option. So cos to the 7t over 7 plus cos to the 8, or rather not the 8, but the 9t over 9 plus our constant of integration t. So now that we have that, this is our final answer, right? So what if instead then, let's erase all of this. And maybe someone keep a mental note of this. Just maybe write it down somewhere. So we compare both solutions. I'll just give you a minute.
Thank you.
Done. So, okay, thank you. So then, let's try the other way. So now, let's say we're using cos squared of t, which is equal to 1 minus sine squared of t, right? All squared. Now, bring it to the expression. We have sine to the 5t multiplied by 1 minus sine to the, oh, sorry. Let's just expand this. Minus 2 sine squared t plus sine to the 4t dt. Right. So now, if you do that, multiply in the expression there, what do we have? We have, right, so we have the integral of sine to the 5t minus 2 sine to the 7t plus sine to the 9t dt. So at this point here, as you can see, we are getting to very high exponents of sine without really a simple way to solve the expression. And I'm sure you guys can see already that this solution, to solve this expression, you're going to need more than, 10, 20 minutes, if you know what I mean. It's a very long process, right? There's probably a way to do it, but it's very long. And you might have at some point to just revert back to costs because you need some sort of cost there to be able to use your u substitution, because you would have sine, the derivative of sine is cos, so you would need to integrate some costs in there so you can use u substitution and easily simplify the expressions. Which means that in this particular case, it's way faster and easier to use sine squared as the substitution, right? Rather than cos squared. And I'm sure if you look it up, and I'm not sure if Dr. Mshongo mentioned it, but if you do look it up, there must be some sort of heuristic. There must be some sort of way for you to figure out which substitution makes more sense for the particular case that you have. It must have something to do with the exponents, right? So there's
Yes.
probably if the you probably choose the function with the odd exponent. So there must be some sort of rule there, right? So please look it up as well. And yeah, you should be able to find. Just give me a minute. I'm trying to see something.
He does have the rules, though.
Sorry?
He does have the rules.
Yeah, so there must be some rule there. Just look it up look it up online or on YouTube. But there must be some rule in terms of to let you know which substitution makes more sense than the other, rather than you losing your time trying to substitute something that is very complicated and doesn't get you anywhere. But I suspect, just don't quote me on this, but I suspect that it's related to the exponents, the value of the exponents. So if you have an odd or an even exponent, because if you look at even the previous example, both of them are exponents. So both of them are odd exponents, meaning that it's possible that we might be able, and you guys can maybe attempt this, we might be able to use both substitutions in this example because both of them are odds. So try that maybe as an exercise and let me know if it works out. But there must be some sort of rule set like that. Yeah. Anyways, hopefully that answers your question. Any other concern? Okay.
No.
Sorry?
I was saying no.
Okay, let's move on then.